All right, welcome to the Denver, Erlang, and Elixir meetup. If you're joining on YouTube, thank you for tuning in. This is for Monday, June 10th. My name's Michael Lubis, and the meetup is sponsored by Praxio.io. So Praxio.io, it's a security platform for Elixir and Phoenix. So if you're using Elixir in production, please take a look and give us some consideration. There's also Elixir developer security training, as well as penetration testing focused on Elixir. Our speaker tonight is Thomas. He will be presenting Finding Your Dream Job with Livebook, SQLite, and Similarity Search. So everyone, please welcome Thomas. I'm going to stop sharing.
All right, how's that look?
Good. Yep.
All right, Keynote works. Cool. So like I touched on earlier, I'm Thomas or Tommy, and I've been plugging around with some SQLite stuff, and I just have been having a lot of fun just decoding Python here and there to convert into NX. And this is kind of like a compilation of my findings and kind of using it to look for jobs. So today I'm going to talk about a little bit about myself, which I kind of touched on, why SQLite vector similarity search, why jobs, what's an embedding, what is similarity search, my process in looking for dream jobs, and a bespoke demo. So I'm a curious Elixir dev coming from a range of different languages. I tend to gravitate towards functional languages. They just play better with my brain usually. I like to run. It's been good running here in Denver. I came from San Diego, so running here in Denver, I'm getting that extra red blood cell count here, so that's been fun. I like to snowboard in the winter when I can. Meditating has been kind of higher up on my list as well, kind of helps with the stress. And I have a husky and a cat, and I try to get in the mountains as much as possible. So how does one go about finding your dream job? And one of the common ways is something called Ikigai, and it's sort of like a very interesting Venn diagram of different sectors of your life and kind of figuring out how they meld together with your sort of experiences. And that's a really good journaling exercise, and I definitely recommend it for everybody. But I'm pretty lazy, and I want to use software to kind of like maybe figure out how to like excavate these things. And that's why I kind of gravitated towards searching. And there's a lot of ways to search for things. Of course, you can use grep or ripgrep, or I think there's another one too, like AG. You can ask ChatGPT, of course. You can use fuzzy search, like Fuzzy Finder. You can use a SQLite query, full text search, and then of course, similarity search. So then that brings us to our next sort of idea. Why SQLite? Well, RDS is kind of expensive and pretty heavyweight. And if you're just like mucking around with some data, maybe it's a little, much to spin up a Docker container with RDS. Why not use a data store that basically runs in the same memory space as your app? So it's very lightweight, and I'm a huge fan of that too. It's free and open source. And like I'm going to go into, there's a pretty awesome SQLite VSS plugin that you can use with SQLite. Let me know if I'm going too fast too. So SimSearch. Well, I did a Google search for SimSearch, and the first thing that I saw was a job finding mod for Sims. So I was like, oh, great. That's exactly what I don't want. Really, similarity search. If you look at these fruits, some of them are different, but similar in certain ways. And so you can think of it as a way to sort of take objects and standardize their representation in a data structure and add some sort of ranking or ordering to them using a sort of algorithm like, and I'll touch on it later, but an algorithm like k-nearest neighbors. And so if y'all can like look in there, these aren't actually real fruit. There's a pineapple, but it's an orange, and there's a pear, but it's an apple. And I've just been having a lot of fun with Midjourney. I'm not sure if you guys have heard of that, but it's just a fun little text to image creation platform. So I thought it'd be kind of funny to put this up and be like, oh, this is very similar to my fruit, but it's not, doesn't even exist. So when I mentioned data structures, the data structure that one would use for doing any similarity searching is called a vector or an embedding. And so this embedding is essentially a collection of floats. And depending on the type of model you're using, this data structure could be different. It varies. And I personally, I went with the sentence transformers model as that seemed to be the sort of go-to one to use. And there's a lot of other models you can use as well. You don't necessarily have to use this one. And Hugging Face is an incredible platform to find these models too. So I definitely suggest exploring Hugging Face and spinning up your own Livebooks and playing around with these. And I put a little example there of an NX tensor, and it's kind of a really awesome wrapper around what you would call an embedding. Like I touched on earlier, it involves different objects, and you kind of boil it down as sort of semantic representation, with the most similar being highest. And this image kind of gives a good idea as to like what that would sort of look like from the end user. You would get all your black shoes together, and then all the shoes in that bigger sort of grouping. But then in the nitty gritty, you could see that the Nike Air Force ones are actually closer together too. And then another thing I didn't mention is actually you can use this for ranking images as well, and not just text, which is super useful. And I think Midjourney's actual website, they have like a similarity search built in as well, which is kind of fun to play with. Like I touched on earlier, k-nearest neighbors is sort of like one of the go-to algorithms for classifying and searching through data. And within k-nearest neighbors, it uses you can sort of assemble your algorithm with some underlying functions that include distance metrics like the Manhattan distance or Euclidean, and even something like cosine, which to me was a little interesting. Like, why on earth does a trig function have anything to do with data? Like, this is so weird. And in the reality, what it's actually doing is it's taking a vector, which is sort of like a point in space. And if you can remember back to geometry, you can measure things between points, including angles. And so literally cosine is just finding the cosine of the angle between two different vectors as they like kind of intersect. So I thought that was kind of cool for me. I was like, wow, how does geometry even relate to this? And it does. So that was pretty fun. That brings us to the next one, which is approximate nearest neighbors. And so KNN is great when you're on more short scale and you're not searching through gigs of data. And you need to be able to like search gigs of data. So you would use something called an index, where a lot of us are backend developers. And so we kind of understand, you have to index your data. Well, how do you even do that with something that's like as big as like an embedding? And so there's been some really nifty libraries that have been released. Facebook released Face, which is it's an indexing library which gives you the power of really fast lookups on embedded data. And today I'm not actually going to do use the IVF or the inverted index, but that one is definitely an exercise left up to the user because that one can greatly increase your lookup speeds. I'm going to be using the index flat just to keep it pretty straightforward today. And I'll talk a little bit about like kind of what it's doing under the covers, but not too deep though. So you essentially, you take your vectors and you quantize them, which means that you're taking the vectors and splitting them up into smaller, more manageable chunks, and then sort of applying some weird groupings. And so I have a picture of this thing called a Metroid. And to me, it's a really cool picture, but really why I picked it is because it rhymes with Centroid. And centroids are basically the sort of geometric shape that these sort of groupings form. And I'll go to the next slide real quick. They kind of look like these cool little geometric shapes, which are called Voronoi cells. And they are based on the data that you have. So when it's saying k-means clustering, k is sort of really dependent on a sort of fit for your data. So k is really it's dependent on you measuring and doing some sort of detective work to figure out the amount of clustering you need to really quantize properly. And I'm not going to go that deep into it, but yeah, it's definitely more case by case. And so then you could get your perfect Voronoi clusters here. So my process for collecting this job data includes scraping the data from LinkedIn, and then creating the embeddings from the data, and then I query it with a library like Face. So how does one go about scraping? And there's many ways, and I try to keep it pretty low level. I try to like reach for the things that I minimally need to get what I need done. So LinkedIn account, and then you can use the awesome rec library. And in the pursuit of doing this, I discovered a really cool rec plugin called Rec Easy HTML, which is a really cool DSL for lifting out the sort of HTML elements that you need. So I highly recommend that plugin. Then I connected it with Oban, which is also a very useful job library. And I created a sort of syncer job, which sort of would reach out to LinkedIn, grab the data, and then every so often would rehydrate any changes. And one thing to note with LinkedIn, they're very careful at monitoring any irregularities with your scraping. So you have to ensure that you're only scraping the minimal amount. So once per second, or even, yeah, I guess about once per second was what worked for me. Here's a cool little code picture of kind of what I was working with. You can see here that I tried to emulate what the browser was doing. And so a lot of put header pipes there. I was also playing around with a proxy as well, which is kind of fun too. And I also added rec telemetry to do some more tracing of what was going on. And you can see the output of the rec HTML, easy HTML. You can easily just reference to your scrape data just by classes, and it'll return it in the form of a map. And so it's very easy to consume. On the next part, we have to create some embeddings. And there I also went with Oban again and I kind of just made a dependent job. As soon as the sync was done, then I would put in a job for the actual embedding of the data. And then I created another module to create the serving of the embedding model. And then after that, you just insert them into the SQLite database. And one really fun thing that I ran into with SQLite is there's an actual limit as to how many insertions you can do all at once. And so it's around 900. And so I ended up having to just chunk it and then do a series of insert alls to insert all of this data. So that was kind of an interesting discovery. I didn't realize that SQLite would have such a limit. I think there's a way to configure that limit to make it higher, but I didn't dig in too much deeper onto that. And with that SQLite VSS plugin that I was talking about, it connects with these embeddings because it's essentially a shadow table that mirrors the main table and just stores all of these indexes as blobs. And then, of course, you have your foreign key, which relates that table back to the main table. And here's a not so great picture because I got a little wrapped there, but just an example of a build serving. A really cool update happened in Bumblebee, the NX library, or sorry, Bumblebee, the machine learning library that I was using for this. And you don't even actually have to create an input template and these other things. You can, it's in main branch, it's built in more so. And I'll put that in the demo. So yeah, like I mentioned, then we can query them with face, which essentially is under the hood of a SQLite VSS. This is an example of an ecto query that you can create using the VSS search function, which gets added when you source those plugins into the SQLite runtime. And I learned about the field function. I've never used it or had a need for that, but it's very nifty because you can pass it arbitrary atoms and it will sort of interpolate the fields on the table. And I thought that was really cool. And then the type function, which is pretty awesome for casting your data. And yeah, that was really helpful as well. And here I'm just doing a subquery and then joining on into that subquery. In my demo, I'm going to actually dumb it down a little bit more. And I'm going to just use just a regular ecto query and not make like a generalized function like this. But this is what I was just trying to optimize for. And now let's do the demo. Okay, let me do that. Okay, is it viewable? Can you guys see it? Perfect.
Yep.
Cool. So
yeah, it's good.
Awesome. So first I'll look at the dependencies here, and I cheated a little bit. I just wanted to set the tone, or rather the base for this. I'm using XLA, of course, some Scholar for normalization, Bumblebee to load my models and to do the actual creation of the embeddings, SQLite VSS with this version, SQLite and Ecto. Cool. So the first thing that we need to do is we need to load our model. So the nice thing is that Bumblebee lets us kind of load a sort of model info. And we will load the model by passing it a tuple, I believe. And I might have to look back at my notes just to make sure that And please, anyone feel free to chime in if there's anything that's like brutally obvious. So we're going to use the all mini LM L6v2. See if that works. Okay, looks like it did something. So here we have a tuple that says okay, and then our model info. So let's match properly on that. Cool. So that's exactly what we need. And the next part, we need to load the tokenizer. So actually, let me review. I gotta cheat a little bit to make sure that I don't. And I'll share this final demo with the actual data as well. Get LFS in there, so y'all can pull this down and definitely play around with it. So just take a quick peek. Aha, so we do need to load the tokenizer. Okay, so do that next. Tokenizer. And it's the same tuple. That's not what I want. I may
same OK pattern, isn't it?
Let's say again.
Is it that same OK tuple pattern on the left-hand side?
It is, yeah, thank you. Beautiful. Now we have a tokenizer. And here's the fun part. Bumblebee will give us the text embedding functionality out of the box now. So I did share that screenshot where I was kind of doing it a little bit more manually. And so now there's a text embedding functionality, and you pass it the model info and the tokenizer. And now we have an NX serving. And we can use this serving to do our inference. So next part is we can do something called nx dot serving dot run. And you can give it the serving. And we need some sort of input. And my input, my husky is sitting here next to me, so Iris loves you guys all. So Iris loves you all. And see if this works. I'm passing in a list. I'm not sure. I don't think it's supposed to be a list. Where is it? It is supposed to be a list. Let me cheat real quick, make sure. There's some things I missed that are also built in. So the actual output, you can feed it different sort of modulating functions and a final sort of delivery attribute. And so you can pass those as options as well. So we want to add in mean pooling. So we can do output pool. It's mean pooling. And output attribute is hidden state. Cool. So what is mean pooling? Like I had no idea what it was until I started mucking around with the sentence transformers library. And this is because I was just trying to use the bare bones all mini LM L6v2 model. And what it essentially is say you take a bunch of data that maybe has repetition in it, maybe noise and stuff. And mean pooling is a mechanism that sort of quantizes it or averages out the data to make it more effective. And yeah, so that's, I guess, how it makes it even better. Output attribute. So I need to get at the actual hidden state. And I'm not actually very sure why it's called hidden state. There's another one called pooled state, but the actual functionalities seem to work better when I use the hidden state. So right now it's more anecdotal. I'm not sure why I have to use hidden state. It just seemed to work better. So yeah, so now we have our updated serving, we have our input, and I need to check to make sure I don't need to pass in. So I am just passing in a non-list. Well, that's kind of funny. So let's just do that. Cool. Here we go. We have an embedding. So this is the first step. And behind the scenes, sort of, I've already created this database of embeddings of the summary, of the actual headline, and to kind of give us something to play with our queries. And then we can use this stuff up here. So I can change this to something like software engineer look in the healthcare. Okay, is 2 words or 1 word? I don't remember. And the
some people do 2, some people do 1. Depends who you ask.
Yeah, in the security industry. Cool. So so we can use this sort of input to kind of query for our data. So here's our just embedding, generate embeddings. Cool. All right. So the next part is the fun part. So we need to set up a connection with SQLite. We need to enable the ability to load extensions, and then we need to load them and then kind of provide the base for Ecto and querying using the VSS_search function. So let me start by doing, we need to create a repo. And we need to do a little bit of cheating. Oh, I did miss one little part, and I'll circle back on that a little later. Okay, yeah. So I'm going to copy these first parts here. Forgive me. My memory has gotten worse over the years. Cool. So the SQLite VSS X package gives you a nifty little mix install, which will download the actual extensions to be loaded into SQLite, and then give you a couple of useful functions to load it into the runtime into Ecto. So this is sort of the first part. Now you have a repo, which kind of works out of the box. So the data, the underlying data, is a post table, which has a summary, has a headline, has the raw description from LinkedIn, and some other smaller things like salary data and whatnot. But we're just going to concentrate on the summary for now. So I'll create an Ecto schema, call it post. Use Ecto.schema. And we need to do something that I always forget. Schema. So here we go. Now we have a post to kind of query. And now Next part is sort of fun. I discovered it. I was looking for mix install examples, and I found this really cool repo that I can link later, which just has like a whole bunch of mix install examples. And so this is like the way that you can use and run a repo in a sort of module. So we'll create a def module main, and we'll create a function called run. And here we need to sort of link the repo. So we'll have a list of children, which is the repo. And then we can do supervisor dot start link, and we'll just pass the children in. And down here, we'll just call main.run and see if that works. So looks like we need a reference to the app. And I think I'm calling it demo. And demo is not available. Let's cheat a little bit. I needed a strategy. That is what I was missing. So we'll go with that strategy in. Okay, it wants a database, and we can fix that. So the database is called softjobs.db. However, we need to, let's see, or actually, I think this is a different error. Look here. Might be because for folder. So let's go and just go right into my deep into my Mac. Okay, and it's actually text embeddings, Elixir. Doesn't like that. Okay, that's fine. I think, go back here. Yeah, I'm not really sure why it doesn't like the path. So I will just switch over to this functioning demo. I got as far as I possibly could, but I'm not sure why the path. I created a brand new Livebook. So what I'm guessing is that this Livebook maybe doesn't have the ability to see this path here. Look at it one more time. Yeah. Okay. Cool. So we have first three parts that I was talking about. We have this main module. We're starting our repo, and now we've created this fun little query. This VSS post table is a shadow table, which you create at the same time as, or in conjunction with the actual post table. And you search it by using this function called VSS search. And that is what you get when you load the extensions required there. And from there, you select the row ID, which is the sort of primary key of that shadow table, and then a distance, which is essentially how far away these vectors are from each other. And then you have to pass it a limit. And then from there, you join it to the post. So let's run that. And there we go. We have a collection of posts that are ranked by similarity. And so my input was software engineer in the healthcare industry. And the first one is senior software development engineer at Amazon, building a healthcare product. Okay. Well, let's do a little bit more. Let's grab my whole resume and see if, not really resume, but my LinkedIn profile, and see if that gets anything different. So I'm just going to copy my experience. And go over here, and instead of this text, let's do this text, the entire enchilada. Let's see what that gets us. There we go. Company in Centennial, not too far away. So I must have gotten some data about like where I live. 5+ years. That's kind of where I'm at. But not Python though. So yeah, it's basically a fun way to kind of query your data other than using regular fuzzy or full text, which SQLite has a baked in full text plugin for, and it is actually very much accessible within Elixir, and you can do the embedding creation as well as the querying all in Elixir. And that's it. Please feel free to ask questions. Go ahead, Chris.
So out of curiosity, first, this is super cool. And like,
thanks.
Awesome, dude.
Thanks.
How well does it handle, like if you have, a healthcare position in Cincinnati or something, how well does it handle things like anything but, or not a, any of those like negations?
Yeah, negations. I don't know how to do that. That would be really useful. And I find that that's a common problem with job boards, is being able to negate things. I would probably, weirdly, maybe I can do a sort of like subtraction of data, like query for data of that specific archetype, and then query the entire sort of batch of it and then just subtract it out. And I would, I guess, maybe formulate my negation that way. So like if you're saying not Python, and then I would have to create, it would have to be like a DSL, of course, and then you would query for all the Python ones, and then make your just regular .all query and then just subtract them out. I guess I would do it that way. But yeah, I don't know if there's something native, actually, and I'll look into that. Thank you. That's a great question. Go ahead, Don.
Yeah, what is a serving? I noticed that that's one thing I'm not necessarily familiar with. You kind of threw out there. I just wanted the thing to keep going. But what is an NX serving? Like what in like human words is that?
So the serving is your inference sort of encapsulated model, which lets you run predictions. And it's something that you sort of create, and then you can use it in a GPU setting, or you can use it just regular CPU. It's like your sort of deliverable that you would put into production and run inference on.
Okay, but then it uses the data, like the pre-vectorizer embedded thing you're looking for, and then on the fly it takes this chunk of data, this input text, vectorizes that, and then does the math to figure out what's the closest.
Yeah, it's a supervised. So basically, you create your algorithms on test data, a test set, and then you create your sort of deliverable, your serving, and then that allows you to run inference on new data.
Yeah.
And yeah, exactly.
Okay.
Any more questions? Anything? I didn't talk about the normalized. So here, I'm kind of like IO inspect it. But so the only way I kind of figured this out was I was parallel running the Python model, or sorry, the Python example. And oh, this is my girlfriend. Say hi. And that's my husky. So I noticed that the data that the floats coming out weren't like the same. They didn't match up. And it wasn't until I applied this normalize function, and then I was getting the same sorts of tensors. That was the only kind of way. And I can bring up the Python code too, but it's linked here in this repo, which I will send to you guys. Yeah, and so yeah, here we go. So this is like the Python example of using a sort of sentence embedding, or the sentence transformers library, and that was the only way I kind of was able to figure that out. I think someone mentioned they read a lot of Python, translate it to Elixir, and that's kind of was the dance here. But yeah, that's it.
Nice. Thank you so much for speaking tonight, Tommy. I'm also going to stop the recording so people can